Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hope everyone's well who's watching this. So, it's been a long time since I've been doing this series. I do apologise. Just ran into a few things to do. But we're back on it. And last time, I believe we talked about natural selection. So, when you look at the title here, you might be a bit confused of what we're doing today. Well, before I came back to it, I thought I needed to add maybe a bit more structure into what we were doing. And so before we just go into evolution a bit more and look more into depth into its problems, I thought it was important to to iterate, because we haven't done this before, about what actually is science. So we're talking about scientific theory in evolution. Let's get some facts and fundamentals down. So I want to put this into two parts. So part one, we'll talk about what the scientific method is. So this will be this video, and what induction is. And then in the next episode, part two, we'll talk about something called different analysis, and then also observations are facts and a question mark. But the first one I'm going to do is what science is in terms of the scientific method, and then we're also going to look at induction. So without further ado, let's make a start. So let's look at the scientific method. So just got a quick picture here, just easy to understand. So this is very basically the scientific method in all of its glory. So this is the one which, depending who you read, but actually if you go back to the most known sources, it actually goes back to someone called Hasan Ibn Al Haytham, rahimahullah, in the Islamic Golden Age, who came up with this. You'll have other people, so maybe Hasan Ibn Al Haytham, rahimahullah. If you talk to people in the Western world, they'll probably tell you Francis Bacon, who came around in like the 15th century, I think it was 15th or 16th. Sorry, 16th or 17th, one of them, Francis Bacon. Either way, both of those were proponents of this kind of method, okay, the scientific method. So, if we have a look through it, right, so it says, what do you do in science? It says you ask a question. So if there's something which has intrigued you, let's take, for example, Newton's gravity, okay? So he saw the apple fall and he asked a question, yeah? He said, how does the apple fall? Then he did some background research and he thought, well, what do we know already about things falling? Does it make sense? Do you know what I mean? How do things fall? How do things move? Okay, so then he did that. Then you construct a hypothesis. So our hypothesis, very simply, is just kind of an explanation. So Newton looked at the apple, did all of his background research, and then said, okay, what I know now isn't really that great. I think there's a force pulling on everything, and that's why the apple fell. Yeah. Then you test your hypothesis by doing an experiment. So Newton said that things fall because something, maybe he didn't call it gravity, but he said some force pulls down on everything. So he conducted experiments to show that there is a force pulling everything. And he had to make sure, obviously, that this experiment was finely tuned to make sure that the results were accurate and reliable. And then he went and analysed his data. So he did all of his experiments. He'd go and analyse his data and think, okay, is the data which I've got together from the experiments, is it saying what I want it to say? Or what I think it should be saying? And let me draw the conclusion. So if he looked at all the experiments he did, Newton, and thought, well, everything is dropping down. There seems to be something pulling on everything to drop down. Yeah? And go towards the centre of the earth. There is a force which is doing this, and I'm going to call it gravity. And then here, I'm sorry it's a bit blurred, but it says repeat the results. Was your hypothesis correct? So you have to be able to repeat it, because you might just have been a fluke. Yeah, the scientific method is all about making sure that what we know and what we teach as science is as reliable as it can be. So you have to try and repeat it, and if you get the same results again, then from here you would then say it's an acceptable, once all of those have been satisfied, an acceptable scientific theory. Okay? Now, this scientific method, which I hope we're all clear with, okay, it works, it's good, it's a brilliant way, yeah, and I would call it brilliant, yeah, it's a brilliant way of us being able to know and observe the world. However, the question which we're talking about, because this has never been in question, to be honest, that it's brilliant, everyone knows it's brilliant. what we're dealing with is this: does this mean that any scientific theory which goes through this process, like Darwinian evolution, which we're talking about, can you take it as a fact? Yeah, is it definite that it happens? And the answer is no, because when you look into something called the philosophy of science, all that means is the way how science works, what the background kind of information and the background mechanisms of how science works is. That's all the philosophy of science means. It actually becomes very interesting. And how this scientific method works is something called induction. So this is the second part which we were going to talk about. Okay? So everything is in science is proved by induction. This is how we prove everything in science. Okay? So what is induction? So induction is a method of proof. Okay? It does not generate answers, it can only prove them, and that is so important, this bit here. So it does not generate answers, it only proves them. What that means is it's not definite. Okay? The opposite of induction, the things which do make things definite, is something called deduction. So that's the opposite of induction, yeah? Deduction. If you make a deductive argument, yeah, deductive argument means it's definitely true. Okay? So for example, let's imagine I say to you, if I go over here, let me just go over here, we'll go with lateral thinking now. So if I say to you, all humans are mortal, yeah? So all humans die. And I say Socrates, who was a famous Greek philosopher, is human. Okay? What's the conclusion that you make from that? If all humans are mortal and Socrates is a human, what does that mean? It means Socrates is mortal, doesn't it? That is a deductive argument. That's why it's in blue, yeah? That is a deductive argument. There is no way that that is wrong. That simply has to be true. Yeah? However, if I say this, have a listen to this. If I say some humans are male, Aristotle is a human, therefore Aristotle is male. Okay, let's pretend Aristotle was actually another Greek philosopher, yeah, and a polymath and a brilliant man. But let's imagine we didn't know that. Let me just say I'm talking about a random Aristotle, a newborn one. Is that a deductive argument? What I mean by it is those three lines, these three. Is this definitely true? No, it's not. Why is it not? Take a moment, pause the video if you want to try and think of it. But the reason why this is not definitely true is because it says some humans are male, but some are also female. There are humans which are female, aren't there? So I've just told you in this that Aristotle, okay, is a human. That's all I told you. He's a human. It doesn't mean that Aristotle, this argument, if you ignore this third line, so let's imagine this third line isn't here, yeah? Ignore it for a second. If I just told you some humans are male and Aristotle is a human, does it definitely mean Aristotle is a male? Definitely. It doesn't, yeah? You can't definitely say Aristotle is a male, yeah? But if I was to say this, all humans are male and Aristotle is a human, then this would be a deductive argument where Aristotle would definitely have to be male, but only if I had this in. So I hope that makes sense. So that's what inductive and deductive means, okay? And so science is inductive by definition. And I'll very quickly, show you how. So let's imagine, for example, this was a real life actual incident. Let's imagine you want to look at swans, okay? And someone who doesn't really know too much about swans goes out into the world and decides to look at swans. And he comes back after a year and says, all the swans I saw are white. Okay? So I'm going to say all swans are white. Okay? But then, and this is true, and this is actually in the world, some swans, yeah, not many, but there is a particular breed which are black. So some swans are actually black. So let's imagine Stuart, okay? So Stuart went around and saw all these swans, yeah, in the pool, which were white. And then someone says, hey, wait a minute. And he shows them a photograph and he takes them to the place. He said, I've seen a swan, because I don't have, black's not going to work here. Let's say he says, I've seen a blue swan, okay? Let's imagine that's black because they do exist. I've seen a blue swan. This theory there now is not correct. And it's not definite. But the point being was that when Stuart went around and looked at all those swans, we all should have accepted that this was an inductive argument. Yeah? Inductive means that it's a good argument. Yeah? But it's not definitely true. And that's what science is. Okay? They are good arguments, which give us reason to believe them. They are inductive. Scientific arguments are inductive, but they are not deductive. Why are they not deductive? Because if you look at the swan argument that we just talked about, you could observe something which changes the way the science works. And the last example I'll give to you, a very famous one, yeah, is when we went from Newtonian equations from Isaac Newton to Einstein and his equations in the 20th century, when Newton's laws and theories about time, and time was a fixed quantity in unit, was changed, and Einstein said that Newton said that time is fixed. And now we have Einstein's theory of general relativity, where time is dynamic and fluid. Yeah, and this worked for 200 years, that Newton's equation, and the people who said that Newton's equations are facts, yeah, and deductive, would have been shocked when this happened, but science wasn't, because scientists know that this is inductive. Just like Einstein's equation are inductive. They're based on certain observations. If new things come, we will change how we work. And this all is the exact same with Darwinian evolution. Darwinian evolution, okay, before we even go into some issues, is inductive. It is not a fact. It is inductive because science is inductive, which means that we have good reason to believe it, but it's not definite. So I hope that makes sense. Any questions, obviously, let me know in the comments. I hope you learn a lot, and inshallah we'll continue with part 2. Inshallah I'll try and upload it as soon as I can. Okay, Assalamu alaikum wa rahmatullahi wa barakatuh.